We will start laying out plots by laying out first a square plot. In this case, 10 by 10 meters or 100 meters square. Now that's only 1/100th of a hectare, which might be on the small size, but that's okay. You can always scale the size of your plot based on the expected density of the trees in the plot. As mentioned in the presentation, the location of our plot should be chosen as randomly as possible. For a square plot, that random location can start as the corner of your plot, for example, where I'm standing. What you then proceed to do is to mark out the 4 sides of the plot, typically in the cardinal directions: north, east, south, and then west. To do that, of course, you're going to need some of your equipment: a compass, your plot tape to measure the distance, and typically we'll have flagging tapes of some kind so that we can mark the corners to help us keep our directions and know which trees are in or out. Hi. Emily is now going to mark off the first 10-meter side of our plot. Once you've defined your plot corners, you can then walk from one side of the plot to the other, typically at the from the starting point, measuring each tree that meets your criteria, usually based on size, in a forward and back direction. In this case, we're just measuring the number of trees in the plot and the DBH, so this should be fairly quick. For trees on the boundary, we're going to use our half in, half out rule to determine if they'll be counted towards stem density and other measures. This first tree that Emily's at, of course, is pretty much completely out of the plot. The next tree along the border is pretty much completely in, so that would count. Obviously, if a tree is half in or half out or leaning in or out, we have to make a tougher determination. If the tree is mostly or more than half of the way in the plot, we'll count it. And the opposite. If more than half of it is out, it's out. For a tree that happens to be leaning, thank goodness that these Norfolk pines are not, we make that determination at DBH rather than at the base of the tree. So now we're going to do a circular plot. So for a circular plot, the location of the plot should be the plot center. And from there, your partner will walk out the distance of the desired radius of the plot. In this case, about 5.6 meters for a plot that's 100 square meters in size. Once your partner reaches that distance, then they just walk in a clockwise direction along the perimeter and tally and measure every tree that intersects the tape. Now this can be a little challenging in a plot that has a lot of undergrowth or small trees, but in this case, this plot is fine. The other advantage about doing a circular plot, besides being able to easily tally and mark all of the trees as you go along, is that you can determine whether border trees are in or out, because you'll have the plot tape with you at all times and can determine the actual distance. The last type of plot measurement we're going to demonstrate is what's called the variable radius plot. As mentioned in the presentation, this is perhaps the easiest tally of trees to make if all we want is basal area estimate. Still helps to have a partner sometimes, though. The key thing with this is to make sure that the location you choose to do your tally is plot center. So you want to make sure you mark that plot well, and as you do your circular sweep around the plot, that you stay right at that location. The tool we're going to be using today to do our variable radius plot measurement is called a cruiser's crutch. It comes in an envelope and it has instructions on how to use it. Emily is going to help us illustrate how to do that. The cruiser's crutch takes advantage of the basal area factor ratio that we talked about in the presentation. This chain actually has multiple basal area factor marks on it. Today we're just going to be using a basal area factor of 2, which uses the entire length of the chain. As the instructions state, hold the chain just below your eye because you want to make sure it's a straight line right at eyesight. Then you hold the scale or ruler away from you up and down. To determine whether a tree is in or out, of course, you line up the scale, which is transparent, with the tree, and then you determine whether or not the diameter of that tree is wider than the line that is marked on the scale. You just sweep and do a tally of every tree that you can see and determine the diameter as you go in a 360-degree direction. The only trick for doing this appropriately is to make sure that the height of the tree that you're measuring is at about dBH. Now, the only other trick to make sure you do the tally appropriately is to choose the first tree that you tally that you can determine or distinguish well. That way, you make sure when you start and you stop, you've gotten all the trees but not double counted some of them. Because we're only using one basal area factor, it's pretty easy to tally up how many trees are in or out and come up with a total basal area estimate. So, in the time it took me to explain how to do the variable radius plot measurement, Emily's already finished her tally. That's the nice thing about variable radius plot measurements. You can do a quick estimate of basal area, then move on to a new location to do it again. As discussed in the presentation, transects can be used to cover larger areas in strips. As with a square plot, you have to follow a straight line in a set direction. Again, this is easiest in a cardinal direction such as north-south, so you'll need a compass as well as your plot tape. Trees on either side of the transect line are then measured if they fall within the set distance from the plot tape, in our case 2 meters. Your dBH tape can be used to measure that distance to determine if trees are in or out. In this case, Emily is going to measure this tree because it falls within our 2 meter radius or distance from the plot tape to the edge of the plot. Other trees may be a little further out, and so it's not clear whether it's exactly 2 meters or not. So with the dBH tape, again, just hook the center of the tree. Again, it's half in or half out, and then measure the distance back to the plot tape. When you reach the end of your transect, you can join your partner, move perpendicular the set distance, and then your partner can walk back in the opposite direction to start taking measurements again. Alternatively, your partner can rejoin you, both move down and start from the same side.